Hi, welcome to our show in Digitalizer. So, today we have a very interesting thing to discuss, and especially we want to see on different use cases where you can learn about IoT technology. So, this is a very practical way to learn the IoT technology, especially because you are involved in the real life scenarios. So without further ado, let's jump into the content. So IoT use case study. So what kind of use case that we have today for today? So we have a boiler system. A boiler system is a special unit which used to boil up the water or any kind of other fluid fluid system to generate expansion within the form of steam or any kind of other substances. So the end product can be electricity or even the heat itself or any form of mechanical movement which trigger another process in the production. So we have a boiler system, and this boiler system is operated with a typical PLC machine, and this PLC machine is responsible to open ventilator, to start up the motors, and also uh, we have special sensors installed in this boiler system where we have the burn chamber pressure. The pressure is measured in bar, and steam pressure, the pressure of the steam which release at the end point of the boiler system, and the water level tank, so how much the level of water is still left on the water tank. This water will be used eventually to boil up in the chamber, in the burning chamber. And the water inlet pressure, like how much the force of water is being entered into the chamber itself. So we have four different variables over here. So according to the use case owner, there are like 20 million data points being generated per day. So it's a lot of data points, and the connection setup is can be retrieved through Modbus. So it's a very standard connection in the industry where Modbus is used to read out the sensor data and things like that. And the Schneider PLC is being used for this operation of the boiler system. So, what is the is current situation? So, what kind of lack of solution is present in this setup? So, as we are growing more and more in the terms of remote-based business operation, so the owner of the business will like to have a remote monitoring of his boiler system from another place, because the boiler system itself situated in a rural area, in a forest area, but the main headquarters of this company is situated in the main city. So he would like to have or give access to his engineering team to have a constant monitor of the boiler system. He especially concerned on the alert system itself, like if the pressure chamber increases above the threshold that he had defined, or if any kind of abnormal activity is happening in the boiler system, they want to have like in situ alarm notification so that they can react or send off a dispatch team to look on the what to be solved. So basically, they want to have a cloud system where it can be monitored through the cloud or through the internet. Yes. So the as I told you, so they want to have like a remote monitoring system. So obviously, we want to build a digital twin, not in a 3D way, in a two-dimensional way. It's something like SCADA system, where they can monitor and see real-time information on the sensor systems, and also they can pre-program any kind of triggers if the sensor measuring points are above the desired level. And Another uh, wish was is to able to do a data analytic study on the historians or the collected data from the census system. So it's a typical machine learning operation, but the thing that need to be predicted out of this machine learning operation is what kind of fuel has been used for the boiler system itself. So there is no direct indication of the oil system or the fuel type that has been used for this boiler chamber. So the uh, so we want to explore a way to find out whether we can determine what fuel type is used by studying or by doing machine learning analysis on the other variables, something like CO2 level, pressure chamber sorry, burning chamber pressure, ventilator pressures, so things which can be correlated to the type of fuels being used. So we have two functionality that we want to accomplish here. So a simple takeaway or simple high level overview for a solution is to, first of all, we have to bring those offsite data to online. So that will be the first step. And how can we do it? So we have a situation where the Schneider PLCs are not capable of sending out data to the cloud or any kind of other online entities. So we have to convert it or expand it so that it able to send it out. So we want to use for this situation, we will normally use IoT edge devices or something like industrial computers, most familiarly known. So we connect those PLC Schneider through the Ethernet cable. So you just need an Ethernet cable and connect to the industrial PLC. And within this industrial PLC, there are some softwares which are pre-configured to able to read the data through the Modbus communication protocol. So by doing so, we have attained the data, and on this industrial PC, we're gonna work more on how we're gonna send out those data to to a publicly available cloud service. So the design principle is, first of all, data is everything. So as we remember, there are like 200 million data points being generated per day. So we have to do some kind of filtering, some kind of like remove the noises from the data, something like those data which not relevant, and also figure out how many time frame we should put, because it is sufficient enough to measure something at a very long time frame than, for example, constant pressure readings. So we have to do some kind of data governance and data quality check over there. We have to make sure the centralized and decentralized data sharing. So on the on-premise, we need to make sure the security level is at highest level, and also the sharing of the data should be in a one way, because we don't want to enable like a command or opening up the operation of the boiler system from the internet itself. So there is a risk of safety. So in order to address this, we have to make sure the connection are certified and also encrypted and also enabled with multiple level of authorization. So the in order to able to see the future steps, we also have to think in a way of deploying this software solution in a microservice based approach, because there is not only one boiler system which is being operated by this company, but there are like four boiler system. So we need to make sure our system is capable of scalability. So we have, for scalability, of course, we have to think about the expansion of the database and also the expansion or the load balancer of the API points and things like that. So everything should be taken in consideration. And of course, the we try to make sure the data aggregation process is being done as much on the edge itself, because on the cloud we just need to send out the data which are more related to the monitoring application. So the data aggregation process will be much more shifted towards the edge, where the simple data processing can be done on the cloud, because eventually we have a cost effective solution over here. So just like I say, like we want to think in the future where we can deploy this system again and again in different plantations. So this is like a much more compact overview. So with suggestion of what kind of softwares and what kind of hardware choices that we can do, and also the cloud system, like what kind of messaging protocols and what kind of messaging queuing system that we can use, and also the end user application. For here, we're gonna use Grafana as our dashboard, and 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 the authorization layer will be on a simple React.js front end. Yeah. So on the machine learning part is something which is can be thought as another layer of the service, like a microservice. So we will leverage the Google Cloud Vertex AI for this operation. So yeah, these are the subsystems that we can try to implement and design IoT platform. For the database, we're going to use Cassandra or InfluxDB, because Cassandra is open source, and I've worked many times with Cassandra, so we're gonna go with Cassandra. For the communication broker, we're gonna use HiveMQ. HiveMQ is a very industrial oriented MQTT server, and for the disruptor, like typically we use Kafka, and for the data aggregation part, we're gonna use Node-RED, because Node-RED is a very powerful like programming layer where we can program the logic behind the data aggregation itself. Yes, for the AI pipeline, we're gonna use Vertex AI, visualization, Grafana, API. We're gonna use Kong as API generator, or maybe Fast API. We need to think about that. And for the governance, like device provisioning, and also over the air update on monitoring the device health. So things like those things being handled by the ThinkSpot. Yeah. So that's all for the introduction video for now. So I hope I have given you a much more detailed overview on the use case. So what will come on the next video of the series is the implementation part itself. So I will show you step by step, like how can you install and program all this batch works, and also show you a live demonstration of the application itself. So stay tuned and do subscribe and like the video, and see you on the next video.